Hello. In this lecture presented by www.free-academy.com, we're going to continue practicing the derivative power rule. We're going to be doing problems 6 through 9 of the text, and the thing that I like about these problems is if you get right down to it, they're exactly the same as the problems we've been doing before. But if you look at all of them, the book has written them in slightly different forms to try to confuse you. So what we're going to be doing in every single one of these is we're going to be placing it into a form where we can use the power rule just as simply as we did in the last lecture. Now we'll start off with problem 6. This one's definitely the easiest out of the two. The only thing that's different about anything else that we've seen before is we have the square root of 2 in front of the x. But the square root of 2 isn't any more special than any other constant. It's just a constant, so we'll treat it like any other one. So y prime will be equal to the square root of 2 times the derivative with respect to x of x plus the derivative with respect to x of 1 over the square root of 2. The derivative with respect to x using our power rule, we have n equals 1 and n minus 1 equals 0. So this will be the derivative. This will be equal to the square root of 2 times 1 times x to the 0 power. This will be plus the derivative of 1 over square root of 2. This is a constant and is equal to 0. X to the 0 is equal to 1. So this whole derivative, y prime, is equal to the square root of 2. And this is something that you should get used to. Whenever you have a constant in front of the x, the derivative is always just going to be the constant. Moving on to problem 7. Y equals negative 1/3 times x to the 7th plus 2x minus 9th. This isn't anything special compared to what we've seen before. We're going to simply distribute our derivative through. So this will be negative 1/3 times the derivative with respect to x of x to the 7th plus 2 times the derivative with respect to x of x minus the derivative with respect to x of 9. So we'll do a couple different power rules here for the first term. N equals 7 and n minus 1 equals 6. So we'll start writing this through. Y prime equals negative 1/3 n x to the n minus 1. This will be plus 2 times the derivative with respect to x, which we know at this point is equal to 1. And we just covered it in the last problem. The derivative of a constant times x is equal to the constant. So this is 2. And the third term is the derivative of a constant that's equal to 0. So the answer to problem 7 is negative 1/3 times 7x to the 6 plus 2. And you can distribute that out further if you like to further simplify things. Now let's move on and let's do problem 8. We have y equals x squared plus 1 over 5. How do we do the derivative of fractions? Well, there is a way when you have to find the derivative of f of x over g of x. And that certainly will work in this situation, but we haven't learned it yet. And in fact, it's even much more complicated than what's necessary for this problem, especially when you see that if you divide this by 5, it's equal to 1/5 x squared plus 1/5. You can always divide the denominator into each term of the numerator. It's perfectly legitimate algebra. So now, we take a look at this. We have n equals 2 and n minus 1 equals 1. So the derivative, y prime, is equal to 1/5 n x to the n minus 1. This will be plus the derivative with respect to x of 1/5, which is equal to 0. Derivative of a constant is always 0. So y prime equals 2/5 x. That was problem 8. Now we just have one last problem to go, problem 9. I love when my cursor disappears on me. So 9, we have y equals ax to the third plus bx squared plus cx plus d. And it should be noted, it says this in the book, that a, b, c, and d are all equal to constants, but not necessarily equal to each other. So to find the derivative, y prime, we take all of our constants out in front, and we multiply through our derivative, c, d by dx of x plus d by dx of d. So this is going to be a matter of just doing a lot of different product rules, and we'll get the answer. For the first term, n equals 3, n minus 1 equals 2. For the second term, n equals 2, n minus 1 equals 1. For the third term, n equals 1, n minus 1 equals 0. In the fourth term is a constant, its derivative is always going to be equal to 0. So y prime is going to equal a times n x to the n minus 1, and that'll be added to b times n x to the n minus 1. This will be plus c, derivative of n x to the n minus 1. And now we just simplify out our algebra. We get y prime is equal to 3 ax squared plus 2bx plus c. And there we have problems 6 through 9.